I will present you. So now we still have a few lectures before the end of the semester, and actually it's now time for you to complete the CPP project. You have all this knowledge about C++ that is necessary to accomplish the project, and in my opinion you also have enough knowledge to successfully code programs in C++ on an intermediate level. You also know where to search for help, how to ask questions, and so on. So I would like to spend the rest of the lectures during this course on introducing the Python programming language to you, and then also to introduce some versioning control tools, maybe these regular expressions and so on. And also, if there will be system-wide problems with certain aspects of a project, then I will also use the webinars as a sort of a global consultation tool. So let's start with the Python. It will be easy for me to talk about some aspect of this language because you already know the C++. And the first thing to compare and contrast these two languages is that the purpose why the given language exists. So the C++ programming language was intended as an object-oriented extension of the C language, more or less. So it is all C++ is a language which should be able to be used when coding operating systems, drivers, also in applications which requires to use like every single bit of the machine capacity. So high performance computations like in computer games, and also for example applications which use video streaming like the one I use now. Not to mention the embedded systems. This is the scope of application where C++ programming language is usually irreplaceable. So C++ is the only solution, at least at the underlying level. So in C++ we have this strong focus on the hardware aspect. For example, if you look at the data types available, we have not only integers and floats, but also floats of single precision, double precision, signed, unsigned integers of different width, and so on. So thanks to that, we have a possibility of using the available resources efficiently, but also it introduces an extra burden, an extra cost on when we are coding. We need to really pay attention to have the type of data properly chosen and concordant when interacting with the data. On the other hand, Python is nowadays, at least, mainly used for rapid prototyping. So you have many available many operations, many data structures available not only in the standard library but also in the core of a language itself. Whereas on the other hand, in CPP, the core language is really poor, I would say, and now the introduction of the standard library somehow helped the thing. But in Python, for example, you have data structures like dynamic arrays and sets available already in the language core. You don't need any extra libraries, even a standard library, to use it. Python is also a cross-platform tool, so it uses Python interpreter to be executed. So you can write the program and you can run it on any machine that has a Python interpreter installed, and you need to recompile your program in order to create an executable file, as it is the case in C++. So Python is all the same program written in C++ and in Python is much more concise in Python. So it takes you less less number of code to less number of lines of code in order to achieve the same effect. When it comes to the performance, some 10 years ago, the performance gap was huge between the Python and C++. It was even like 30%. So the same task, the same algorithm coded in C++ could perform all like nearly twice as fast, even twice as fast as in Python. But the Python evolves, and also the code of the Python interpreter was significantly improved. And nowadays, these differences are like 5 to 10%. So they are no longer crucial when deciding which programming language to use. The main question is what we need to achieve. So what is our goal, and we need to choose the tools based on how simple it is to achieve the same effect, right? So it's the same thing as you want to hang an image on the wall, and you can choose either to use a screw or to just use a nail. And in some cases, one will be more preferable. In other case, another solution. But you definitely shouldn't use, for example, a screwdriver to place a nail in your wall, and the same thing, you shouldn't use a hammer to place a screw in your wall. So and it shouldn't be an argument that currently I don't have a hammer, so I will use a screwdriver. No, you just then go and buy a hammer, or you just borrow it from your colleague, or use some other tool that will be appropriate for putting a nail inside the wall. So, okay, I guess that's enough of me talking about this theoretical considerations. Now let's get to the Python, actually. In the most simple form, you can just install the Python. You don't need any IDE. Here you can see the window of the PyCharm IDE, which is like the equivalent of CLion, but for Python. All you need is the so-called Python console, and as the name suggests, it's the console tool. So I can run the command line, I can type the Python command, and bam, the Python interpreter appears. And in Python, one of the most simplest program is just this famous hello world. And that's it. So it's enough that you type a given command, like here I typed print and then hello world. I press enter, and that command is instantly executed, and I can see the result. In a moment, I will switch to the console in the PyCharm so that the font will be larger. But it's just to show you that you don't need any external tools to actually code something in Python. Now, of course, the use of IDE is preferable, it's the same as in C and C++. You can code in a notepad and you can compile the programs using the command line, but it's a so-called pain in the ass, and actually you try to avoid it as much as possible. So I will now demonstrate further examples in the same Python console, but just available inside the IDE. So, for example, let's say we'll create a variable x that is equal 1, and also I will create a variable y that will also be equal 1. Now, some strange things happen. I am waiting for some sort of communication with the interpreter, it seems. Maybe it's because I have an interpreter open here, I'm not sure. Right, now it works. So as you can see, although the font is tiny, I have here the watch window with all the variables, so I can see that a variable x was created. I can also create another variable y, and also I can see that that variable is present. So the important thing when using the data in Python is that it's quite different from what you know from C++. So in the C++ programming language, for example, you have to specify the name of the variable, but also its type. Whereas, so it was the so-called static typing. So the type of the data is determined statically at the compile time. Whether in Python you don't need to provide the type of the data. In dynamic typing, the interpreter automatically adjusts the type of this identifier based on the type of object we assigned to this identifier. So that's an important difference. And if I will now change this, the value associated with this identifier, it's perfectly legal in Python. So let's take a look. Now x was equal 1. So when I will call the type function on x, I can see that x is of class int. So it's an integer. Whereas when I will now write x equals abc, no error appeared. Now x is of type string. So it turns out that these identifiers can be considered more like a reference in C++. So in C++, each such an instruction allocated a certain amount of memory where this object was stored. And in C++, if we had these two instructions, so first we create a variable x with a value of 1, and then variable y having the same value. In the computer memory, these two objects were stored in a separate space. So we could illustrate it that in the RAM memory we have something like this, and here we have these identifiers help us refer to these places inside the memory. That's how things worked in C++. Whereas in Python, it looks a bit different. Namely, we allocate a new object inside the memory only when we need to. And since these two ones are semantically the same object, so in the computer memory we have only one object with like one integer with value of 1, and both these identifiers refer to the same object. So once in Python we can check sort of the address of an object using the id function. So let's say I will write x equals 1. The id of x is this. Then y equals 1. The id of y is exactly the same value. So that's the situation here. So in some cases, the program written in the Python can use less resources than actually a program in C++. So here in Python we only need to store in this case one object and two references to the same object, whereas in C++ we had to store two distinct objects in such a case. Now continuing with this type system in Python. We have the int type, so we have the string type. So we don't have the C-style strings, it's already a class. So it's more like it's an equivalent of the string class. And then we have the floating point numbers. We basically have only two numeric types in Python: integer and float. That's enough. We use integer when we need integer arithmetics. We use float when we need a floating point arithmetics. That's all. So I can use the Python as a simple calculator, and I can use it easily. I have, for example, the operator, the power operator. So I can perform operations like this easily, and of course the same is with floating point number. We can use this int type to store both positive and negative numbers. Actually, so we have this these few really basic types. What is also important is that Python is sort of fully object-oriented language in the sense of data, at least. What I mean, of the data hierarchy. I mean, all these types, so integers, floats, strings, here and so on, are actually descendants of the same type. So we can use the type function again to check what is the parent type of int, and it turns out that it's the so-called type class. Oh, maybe I just mixed two things together, sorry. So the first thing is like this. Rather, we have isInstance function, and we can ask, for example, whether one is an instance of the integer class, and that's true. But now we can ask whether one is an instance of the object class, and the answer again is yes. And then we can answer whether int is an instance of the object class. Again, the answer is yes. So when we'll take a look at the hierarchy of classes in Python, we have this topmost class object. Then, for example, here we have an integer and float. Here we have also a type class. So as you can see, everything is in Python is either an instance of the object itself or an instance of one of the derived classes. So classes that derive from the object class. And it really helps us to accomplish certain types of operations about which I will talk in the next weeks. But that's important, that in this sense, Python is fully object-oriented. There are some other aspects which will show us that Python isn't actually really fully object-oriented. For example, when it comes to encapsulation, it lacks a mechanism of the proper mechanism of data encapsulation, but that will be a topic for a different webinar. So now you have this data, and apart from these really basic types, I mean numbers and strings, you also have the more complex types, namely the containers. And I can, for example, create a list of integers. So, and that's an equivalent of std vector / std list containers from the standard library. And of course, I can, for example, append an element to that list, and for example, I can check the size of the list. So the list type is available in the language core. I didn't need to include or import any sort of extra functionality. I also can easily create a set of elements. So let's append another one to that list, and now I can convert it to a set. And as you can see, I have now a functionality similar to the std set from the C++. So it's just a collection of unique elements. And finally, you can have a tuple of elements. So tuple is similar to that what you know from C++. It's just a sequence of elements of heteros type. And finally, you have the so-called dictionary, or maybe I will write the names here. So the dictionary is just a mapping from one object to another. And actually, in Python, since everything is an object and you have this dynamic typing, you don't need to. You are not restricted with, for example, here the type of a value associated with a given key. So it's equivalent of std map, but of course with the restriction that here also the elements in a list can have different types. So you are much more flexible in what you write. In the next webinar, I will show you some basic functionality of all these containers, and I will also talk a little bit more about the data model in Python, because many, for example, those instructions used to control the flow of the program. I mean, the conditional instructions, the loops and functions, they work pretty similar in both Python and C++. So I would like to focus on those issues which are fundamentally different in both programming languages. And I would also like to show you some basic use cases of the Python, and then it will be, well, up to you to read some more about Python, but you will have a good basis for this. So I will stop at this point, and we'll continue with these examples in the next week.